Okay, so now let's do some more challenging uh, solving inequalities with one variable. So on this page, you can see that we've got three examples and one think pair share. So I'm going to go through these three examples and then allow you to pause the video and solve the think pair share on your own, and then resume the video and check and see if your solution is correct using any of these three examples as a model for you to solve this think pair share. Okay, so let's look at this first one. So we've got 8p plus 3 times p minus 12 is greater than 7p minus 28. So again, just think of this as though it were just an equality, okay, an equation, all right? So the first thing we would need to do is we need to combine like terms, but we can't do that because we have to kind of resolve this distributive property here. So we're going to have 8p plus 3p minus 36 greater than 7p minus 28. Okay, so here we've got like terms on the left, so that's going to be 11p minus 36 is greater than 7p is 28. Let's see here, minusing 7p from both sides. That's going to be 0. So we're left with 4p here. And I generally don't like doing this, but one thing that you can do is we can do two operations on a line. Okay, if you can keep that straight, that's kind of bordering what I feel comfortable doing. But I'm going to do it in a different color so you see what I'm doing. And then this is going to be greater than, and negative 28 plus 36 is 8. Now, notice you might ask, well, Dr. Morales, you just subtracted both sides. So why didn't you change the sign? Remember, you only change the sign when you've got a negative number when you're multiplying or dividing. Okay. Adding and subtracting, it doesn't change. This is the only rule down here that you need to pay attention to. When you're multiplying or dividing by a negative, then the inequality reverses itself. So because I subtracted here, the inequality did not reverse itself. It stays the same. Okay. And so now all I need to do is divide both sides by 4. And of course, now I'm dividing by a positive number, so nothing's going to change. And so we're going to have p is greater than 2. And that's our answer. Let's move down to the next one. So, we have a lot of simplification to do here. So first we'll apply our distributive property there and distributive property there. I'll use different colors to help us keep things straight. At least I'll try to. So negative 2 times 5 is negative 10. Negative 2 times negative x is a positive 2x. We've got less than. 4 times x is 4x. 4 times 9 is 36 plus 6x. All right, now we need to combine some like terms. So 8x and 10x, or 2x on this side is 10x. We've got minus 10 less than. Here on the right side, we got these like terms, 4x and 6x. That's going to be 10x plus 36. And let's subtract 10x from both sides. So this is going to do something rather unfortunate. It's actually going to cancel our variable x on both sides, leaving us without a variable to solve for. So this is actually reminiscent of a type of answer that you could have gotten that we got in an earlier section. So the first thing to note about this inequality is that this inequality is true, right? Negative 10 is less than 36. Okay, so what does this mean? So first, this is a true statement. And in this case, all of the x's cancel out. And what this means, this is the important part. What this means there are an infinite number of values of x that are solutions. And so the way that you would write the solutions for something like this is you would say x is equal to the interval negative infinity to infinity. So values of x just go in infinity in both directions. And this is an example of what is called an identity, almost that equation. This would be an identity, I guess we'd call this an inequality. All right. So this is a special circumstance. So I wanted to give an example of a special circumstance because you might come to an answer like this and think, uh-oh, I did something wrong. All right. That still might be the case. Okay. But if you double check, all of your algebra, and this is truly what you're left with, all right, that's okay. It just means you've arrived at a certain scenario, and this is what that scenario means. All right, let's look at this next example here. Now, this is going to require using a skill that you learned earlier, and that we would like to not work with fractions, okay? And in order to work with these fractions the best, we need to find a least common multiple for all of these denominators here, right? So part of the reason why I gave this example is to kind of clear the cobwebs and kind of pull something back from a previous lesson to help keep this fresh, because this is really a useful skill to know how to do this. Okay, so how do we find the least common multiple? First, we need to do is we need to do factor trees for each of the denominators. So for the denominator 3, well, 3 itself is just a prime number, so we're good there. We'll do a factor tree with 8. So 2 times 4, 2 times 2. We need to do a factor tree with, let's do 4, because I'm just thinking of space. That's just 2 times 2. And then we need to do a factor tree with 24. So that's 2 times 12, which is 2 times 6, which is 2 times 3. All right. So our least common multiple is going to be every unique prime factor that appears and the maximum number of times that that factor appeared across any tree. Okay, so for example, we have the common factor of 2. Okay, and 2 occurred 3 times there, twice there, and 3 times there. So that means 2 occurred the most times. It occurred 3 times. So we're going to have 3 2s in our least common multiple. And then the next prime factor was 3, and it occurred once there, and we would say it occurred once there. So because it only occurred once in any factor tree, we're going to have a 3 right there. So it just turns out that our least common multiple is going to be 24, the denominator of one of our fractions. It just turned out to be that way. So what we're going to end up doing is we're going to end up multiplying this entire equation by 24. Okay. So I'm going to run out of room quick. Okay. So let me try and see if I can squeeze all this in. So we're going to have 24 times 1/3 x minus 24 times 1/8 x greater than 24 times 5/24 x plus 24 times 3/4. Okay, so let's see here. 3 will go into 24 8 times. 8 goes into 24 3 times. The 24s will cancel there. And 4 goes into 24 6 times. So over here on the left, we're going to have 8 times x. So we got 8x. And 3 times x is 3x. So we got minus 3x there, which is greater than. We have 5x on this term. And then 6 times 3, that's going to be positive 18. Okay, 8x minus 3x is 5x greater than 5x plus 18. Subtract 5x from both sides. And oh no, we're going to have a similar situation to what we just had in the previous example. So we're going to have 0 greater than positive 18. Except in this case, 0 is not greater than 18. This is a false statement, contrasting to what we have here. So what does it mean when our variable cancels itself out and we're left with an inequality which is false? So here, all the x's cancel out. And this means there are no values of x that are solutions. So there are no values of x that are solutions. So there's no solutions for this inequality here. So, I've given you one example, where there is a solution, and I've given you 2 examples where it may not appear as though there are solutions, and you have to kind of look into it a little bit more carefully and determine whether it's a true statement or a false statement in order to say whether there's an infinite number of solutions or there's just no solutions at all. Okay. So now is the point when you try and apply what I've just taught you using the model examples that I've given. So refer to those. At this point, pause the video, and when you resume, we'll resume with a solution. So go ahead and pause. Okay, you're back. So let's look at solving this one. All right, so we're going to go ahead and distribute this 2. And I'll try and use different colors here to help show you what happened here. Oops, I was going to use different colors. All right, so we have some like terms here. So this is going to be 11y plus 12 is less than or equal to 5y minus 24. Okay, I'm going to subtract 5y from both sides. So that's going to be 0, and this will leave me with 6y plus 12 less than or equal to negative 24. Now I'll subtract 12 both sides. By both sides by 6. And we get y is less than or equal to negative 6. That's the answer you should have come to. Okay, let me know if you have any questions.